Okay, my dear. So here we are on our second review. So let's get started. This is review number 2. Okay. And if you did these converting the following linear equation into slope-intercept form, then here's how you do it. So I want to get y alone. Here's y. We have minus 4x equals negative 7. I'm going to add 4x to both sides. Y minus 4x plus 4x is 0. Negative 7 plus 4x, I cannot combine because they're not like terms. So negative 7 plus 4x. Y plus 0 is y. And then I got negative 7 plus 4x. But they want, y equals mx plus b form. So I can rewrite this using the commutative property of addition. And so y equals 4x minus 7. Okay. And this side, y is not alone on its side. So I'm going to use D4C. Okay. Distribution, no distribution to do. No combining of like terms. Now I have a constant. This is my constant. It's all being added to y. So I'm going to subtract 12x from both sides. 4y plus 0 equals, well, I can't combine these because they're not like terms. Okay. I have 4y plus 0 is 4y equals 16 minus 12x. I'm going to divide by 4 to get rid of the coefficient. If you recall from the other video, when I have something like 1 plus 1/2 plus 3/2, I have to add the numerator and keep the denominator. Likewise, if I have 1 plus 3 over 2, I can separate. I can go backwards to 1/2 plus 3/2. Okay? So I can rewrite this actually as 16 plus negative 12x over 4, and then separate it into 16 over 4 plus negative 12x over 4. And simplified, y equals 16 divided by 4 is 4, plus negative 12x divided by 4 is negative 3x. Rewritten in y equals mx plus b form would be y equals negative 3x plus 4. You do need to know this for your test. Okay. Graphing from a table and a solutions. So is 3, negative 1 a solution for 2x plus 3y equals 5? Show work to support your answers. Let's pick a pretty color for this. How's about brown? Love brown. So if it is a solution, you know what? I'm going to make this a little thinner. Okay, so a solution, that is not thin, huh? Give me 1 second, my dears. A solution satisfies the equation. Okay, meaning makes it true. Okay, so that's just like how we would solve any old equation. So if it makes it true, oops, my computer is turning funny colors. I have this one app that changes colors so that my eyes don't die after staring at your smartboard all screen. So I am going to see if it makes it true. Now, if it makes it true, how do I do that? That means I have to check. So I'm going to substitute this. This is my x, this is my y, into this equation. 2 times 3 plus 3 times negative 1 equals 5. Now we're going to simplify. So first, we substitute. Then we're going to simplify. 2 times 3 is 6. 3 times -1 is -3. 6 plus 3 is 3. So, is it true? No. And the reason being, it is not a solution, okay? The check did not work. So what does that mean? This means that 3 and -1 does not lie on the graph of 2x plus 3y equals 5. And what type of graph would this look like? Well, we would look at the exponent on the x. Since the exponent on the x is 1, it is a line. So therefore, it is not on the line. Okay? And so that's how we know if it's a solution to a line. A lot of colors there. Let's try this one. So this one goes way, 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 way back to when we did linear equations from a table. This page, if you had trouble. Okay, so we're going to go back. We're going to create inputs. We're going to graph them. So we're just going to create some inputs here. Let's use, oh, they gave us inputs, sorry. 0, 2, 4, 6, 8. We're going to write this in here. 1/2 x minus 6. Y equals 1/2, my x is 0, minus 6. Well, 1/2 times 0 is 0. Minus 6 is -6. My coordinate point becomes 0, -6. Likewise, 1/2 times 2 minus 6. 1/2 times 2 would be 2 over 2, which is 1. Minus 6 is -5. So I'm just going to continue on. 1/2 of 4 minus 6. 1/2 of 4 is 2. Minus 6 is -4. 1/2 of 6 minus 6 is 3. Minus 6 is -3. And 1/2 of 8 minus 6 is 4. Minus 6 is -2. Next, I'm going to plot these on the line. I'll put this one. Okay, so we have 0, -6. 0, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6 here. 0, -6. 2, -5. 4, -3. Oh, wait, I'm sorry. Over here. -4. 4, -4. 6, 6, -3. And 8, -2. So I'm going to connect these with a line now. As best as I can. Remember to extend it. Okay. And remember to write the equation of the line. Y equals 1/2 x minus 6. Okay? Done. Now let's see. Does this represent a function? Well, let's see. 7, 12, 6, 12. What is a function? Well, if you go back, I'm just going to choose a different color. If you go back to our functions, relations and functions chapter, it says here that a function, just from the map, a function is when there's a correspondence between two sets x and y. Each element of x is matched to one and only one element of y. AKA, for each x, there is one and only one y value paired with it. I'm just going to rewrite that over here so we really reiterate it. Okay, function. Each x is paired to one and only one y value. Okay, however, more than one x can have the same y value. Okay, so I'm just gonna, actually, let me erase this. All right, it's okay for more than, let's just do this here, move this over here, more than one x, there you go, can have the same y value. I forgot the y. So what happens when you work on Friday nights, guys? One y value. Okay? It's just not okay for an x value to have two y values. So does this represent a function? Let's see. These are the x's and the y's. Okay. Now, do any of the x's repeat? Here's a 7. And, oh, here's a 7. So, if the x's repeat, that means that x is paired with 12 and x is paired with 10. That cannot happen, so it is not a function. And the reason is because, x is paired with more than one, y value. So I'm going to say more specifically, x equals 7 is paired with more than one y value. What about this one? Does it represent a function? Well, do any of the x's repeat? No, they don't. So I'm going to say, I'm sorry, I said no aloud, but I meant to write no, yes. Why? Because each x value is paired with one and only one y value. Sorry, my handwriting does not get better once I leave school. Does this represent a function? Now, wait a second. I got no x's and y values. But wait, you remember the trick? This beautiful, beautiful vertical line test. I'm going to draw a bunch of vertical lines. But as long as I can draw one vertical line, if the graph of this relation crosses it more than once, which here it's crossing it 4 times, that means that it is definitely not a function. Remember, this is called the vertical line test. And the reason is it does not pass the vertical line test. Okay, over here, is this, which order pair is not a function? Well, let's see, not a function means that x will have 2 y values, at least 2, maybe it has 3, maybe it has more, etc. Okay? Let's see, any x's that repeat, any x's that have more than one y value. Oh, I see one. 3 and this one. What's D? Alright, now we're going to label these. Label the slope of each line as positive, negative, 0, or undefined. Well, our slope dude going down this way is saying nice negative. When he's going horizontally, he's having 0 fun. If he's going up the hill, he's saying puff, positive. And when he's going off the cliff, he is undefined. Please know these. Okay. Don't worry about 8 right now, though I do think you can do this. So we have the slope, which rises. Obviously, that's going to be a rise of 250 feet up. Ooh, the side of the mountain for every 75 feet in a horizontal change. So we're going to find the slope. So slope is equal to rise over run. What's my rise? Well, I'm going 255 feet up. What's that represented as an integer? Oh, that is positive 250. For every 75 feet horizontal, horizontal is left and right. That's going to be my run. Every 75 feet, so that's going to be positive because you can't have negative feet. That's crazy. We got 250 over 75. Can we reduce this at all? What number goes into 250 and 75? That's right. 25. 25 goes into both. Sorry, I was thinking 3 because 75 divided by 25 is 3. 250 divided by 25 is 10. Can't be reduced anymore. Slope is 10 over 3. Leave it as a fraction. Okay, here we are finding the slope. I think I can just do these for you. I'm pretty sure you will have no problem with me just doing them. Okay. Equals what? We got 9. Oops, not 9. We got 6. And we got, that's a 6, I promise, not a B. 6 minutes, this is 9. 6/9, 2/3. Okay. We have m equals y2 minus y1 over x2 minus x1. We have 5 minus 2, negative 5 minus negative 1. 3 over plus is negative 5 plus 1 is negative 4. Okay. And we have these other slopes. So I'm just going to pause here. And I'm going to complete the review sheet for you. Okay. Oops, sorry. I'm forgetting how to pause it. Hold on. Give me a second. There we go. Okay, so I worked on some of the problems. And so here's the slopes for 9 and 10 we just went over, right? 9 and 10, 2/3, negative 3/4. Let's scroll up. To find the slope for 11 and 12, what I did here was let me make it a little red. How about that? Can you see that little dot? Okay. What if I can make it bigger? Probably not. Let's see. I'll try anyway. Oh, there it is. Good. I did rise over run for the graph. You don't have to. You can use m equals y2 minus y1 over x2 minus x1. I just like rise over run for this. But you cannot combine them, okay? So the slope for 11 is 2/3. The slope for 12 is negative 1. I just chose any points. Same here, I chose any points. I used y2 minus y1 over x2 minus x1 for both. I got 2 here, and I got 1/4 here. Writing the equation of a line. It tells me if the y-intercept of a line is 3/2 and the slope of the line is 2.5. Oh, sorry, 3/2. What am I reading? 3 and 8/10, and the slope of the line is 2 and 5/10. What is the equation of that line? So I wrote out B is 3 and 8/10. I got that because it says the y-intercept is that. Slope is m, and that's 2 and 5/10. So I wrote out my equation. I substituted in. To find the equation here of this line, I chose any 2 points. I again did rise over run. My y-intercept was 0, negative 3 here. I wrote m, b, I substituted in. And now here, write the equation of the line with slope and y-intercept given. Where's my pen? Here we go. The slope is negative 1/5. If they're giving you the slope and the y-intercept, be nice to yourself. Use y equals mx plus b. Use the slope-intercept form. That's what it would be here. In part B, when you have 0 as your slope, it gets rid of that x, so it just becomes 4, just the value of your y-intercept. Over here, 18, we have, again, identify the slope. I did rise over run. I chose the first point on the left and the last point on the right. I found the slope to be a half. Then I had to identify the y-intercept on the line. It was 0, -1. And I combined them to slope-intercept form. Okay? All right, for the table shown below, same idea. We are going to choose any 2 points. I don't care. I have to find the slope. From a table to find the slope, I'm going to use the slope formula. So I'm going to say this is my x1, my y1. Let's say this is my x2 and my y2. I don't care. 20 minus 10 over 20 minus 12. It doesn't matter what I choose. 20 minus 10 is 10. 20 minus 12 is 8. My slope, therefore, My slope, therefore, is 5/4. Okay, I'm just going to lasso this. Oops. I'm sorry, 5/8. I'm going to lasso this and move this here. Okay, I'm going to lasso this part. I'm going to lasso, sorry. You guys are seeing this, oh boy, classic Miss Fong. There we go. Okay. Next, I'm going to have my B. Uh-oh, my B is not here. So what do I have to do? I'm going to have to solve for it rather. Y equals mx plus b. Y equals, put my slope in, 5/4 plus b. Oh, 5/4 x plus b, excuse me. And now, I'm going to choose anything to be x and y. I can choose one of the points I already used. I can choose new ones. Why not use new ones? I like it. I'm going to have 5 equals 5/4 times 24 plus b. Well, 5/4 times 24, 24 divided by 4 is 8 times 5 is 40. Sorry, not 4 is 8, it's 6 times 5 is 30. Equals 5 plus b. I'm going to subtract 30. I get -25 equals b. Finally, I substitute my equation. Y equals 5/4 x minus 25. How do I know if I'm correct, though? That'd be cool if I could tell that I was correct. Well, lucky for you, we can do a nice little check. Okay, so let's check here. How do I check? I pick a point that I haven't used. Let's pick that one. Okay, I'm going to use what I think is the correct equation. And I'm going to substitute in 15 equals 5/4 times 16 minus 25. Well, let's see. 5/4 times 16 is 16 divided by 4 is 4. I'm going to get 20 minus 25. There we go. And 20 minus 25 is -5. So did I do this problem correctly? Well, let's go back. I'm not getting it to be equal. So let's see what might have happened. Let's look back at our slope. y2 minus y1 equals over x2 minus x1. So I got 10, and I got 8, and I got 5/4. So that looks fine. The other thing we could do, oh, well, wait a second. Look what I put for x2 here. I put 20, but x1 is 20. So that's why checks are important, because you can always see where you messed up. And it's super important that you also write out your work so you can find where you went off. So it's supposed to be 12 minus 20. That's going to give me a -8 and a -5/4. So now let's look at the b. So we have y equals -5/4 x plus b. I'll use the same ones. 5 equals -5/4. The x is now 24 plus b. 5 equals, let's see, 6 -5, -30 plus b. To solve for b, I'm going to add 30 to both sides. We get 35 plus b. Ooh, looks promising. Let's check it again. Okay. We have y equals now, so what was our final equation? Y equals m, which is 5/4, -5/4 rather, x plus 35. Okay, oops, sorry, wrong color. Equals b. Okay, I just did that again. I'm being silly today. So let's check it. Y equals -5/4 x plus 35. If y is 15 and x is 16, you can put all this straight into the calculator. You get -20 plus 35 is 15, which equals 15. Correct, so our check works. I'm going to continue with number 20, and then we'll rejoin for number 21. I'm actually going to do 20. Yeah, we'll do 20, and well, yeah. All right, I'm going to be right back. I'm going to do 20, and we'll reconvene for 21. Okay, so here is the answer to 21 for x plus 7. I'm not going to show you the work for that because I believe in you. Number 21. Write the linear equation from the table below. Explain what it means in context. Okay. So, what it means in context. Well, let's see. How would I find the linear equation? Well, I'd have to find the slope and then the y-intercept, correct? Well, I'm actually going to leave this one for when we come back from after the test, because we're going to work on word problems separately. Now here, we have determine the slope and y-intercept from the graph shown and write the equation. What's the slope? So I want to see the slope between here and here is 2/3. This is +2 here. This is +3 here. We have rise over run 2/3. Y-intercept, well, where is the y-axis? This is the y-axis. And where does that line hit that? Oh, right here. At 0, oh, sorry, at 3, 0, 0, 0, the origin. So what's the equation? Y equals 2/3 x. What does that mean? Well, in terms of the scenario, what is the slope? The slope is y over x, which is sales, that's the unit of money, per day. So what that means if the slope is 2/3, then that is $2 per day is made, and what are we talking about? In book sales. Okay? Moving on. Graphing using slope and y-intercept. Well, let's see, what's the slope here? The slope here is 2. The b here, the y-intercept, is 1. So I'm actually going to do this. I'm going to mark the y-intercept. B is 1 here. And from there, I'm actually going to draw points without a slope. So I'm going to, that 2, when the m is 2, we have rise over run, right? So that means it could either be 2 over 1 or negative 2 over negative 1. So I want to say, let's see if we go up 2 and over 1. That should be where my next point is. Right there. We'll continue. We're going to go up 2 over 1. That's where my next point is. Up 2 over 1. That's my next point. Up 2 over 1. That's my next point. Okay. On the opposite side, we can go down 2 and to the left 1. And that would be my next point. We'd go down 2 to the left 1. It's another point. Down 2 to the left 1. It's another point. And once I finish this, I'm just going to graph them together to make a line. Like that. Okay, and then I'll label it y equals 2x plus 1. Okay. You want to see me do it again? Let's see. What's my slope? My slope is negative 2/3. My y is negative 2. And look at my rise over run is negative 2 over 3. That could either mean that it's negative 2, 3, or 2, negative 3. Those are the two ways to write it. So I'm going to start at my y-intercept, which is b equals negative 2. And I'm going to use my slope. I can either go down 2 and to the right 3. I'm going to try that. Down 2 and to the right 3. So that would be where my next point is. Let's keep going. Down 2 and to the right 3. That's my next point. Down 2 and to the right 3. That's my next point. Well, I've run out of room here. Let's go back to my y-intercept. This is my y-intercept right here. Okay, special. I can go up 2 and then to the left 3. Up 2 and to the left 3. Go up 2 and to the left 3. Up 2 and to the left 3. Would be another point. Once I run out of room that way, I'm just going to connect them. And that is my line. Y equals negative 2/3 x minus 2. Okay, so take a second and look at that. Okay, so I went ahead and I did converting to slope-intercept form because we did a couple of problems like that already, both in the last video and before. So those are your answers for that. And then I moved on to writing it from 2 points. So I said, you know what? I'm going to show them how to do it both ways. So they can do it either slope-intercept form or point-slope form. Okay, so slope-intercept form and point-slope form, either way, we both need the slope. So I found the slope up on top. I got -4. Now down here in slope-intercept form, I had to solve for b. And I got -15 for b, so I got y equals -4x minus 15. For point-slope form, all I had to do was put one of the points in and simplify. So I don't have to solve for any b. So you could either get y plus 19 equals -4x minus 1, or you could get y plus 7 equals -4x plus 2. Now they all look very different, right? You have this answer, you have this answer, and this answer. We went over this in the last video, but I'm going to do it again, explaining how you know that they're all the same. So let's move over here. Can't do much about the y-intercept problem, right? But we can do some stuff over here. Let's see, we got to distribute first for solving for y. We have y plus 19 equals -4x plus 4. Subtract 19 from both sides. Y equals -4x plus 4 minus 19. This is -15. Hey, what do you know? It's the same thing. On this side, let's distribute. Oh, I forgot an equal sign here. There we go. That's better, right? We got y plus 7 equals -4x minus 8. Subtract 7 from both sides. Y equals -4x minus 15. So these are all equal, the same. Okay? And lastly, I left you to do this problem however you'd like to. This is your answer that it should be. Okay, so that's the end of this review. I'll upload the next review soon.